Okay, so picking up where we left off yesterday, we're going to now talk about the unit vector. So a unit vector is the same direction as the original vector, but with a length of 1. So if my original vector was like 3 units long, it would be made up of 3 unit vectors. So if V is a non-zero vector, so an existent one, then the vector U is the unit vector for that. And so all it is you're taking the vector's components and dividing by the magnitude to make it 1 unit long. Alright, so if we have this as our vector, so we're saying that if I start at this point and I go backwards 3 and up 4, then I end up with this as the resultant, like that's my vector. Alright, so this will be vector V because I went back and up. Okay? And so if I want to cut this is 5, so I need to cut this into 5 equal pieces. And so we're trying to figure out what that new component form would be. And I also want you to show that it has length 1. We're going to do that on the first 3. We're not going to do that on the bottom 3 because it gets very redundant. So, just to find the unit vector, the first thing we need to know is what is the magnitude of this vector, which I just told you is 5 because it's a 3 squared 5. But remembering that formula, we're going to do the square root of negative 3 squared plus 4 squared, so that's the square root of 9 plus 16, so the square root of 25, which is 5. Okay, so then to get that unit vector, you're going to take the original components and divide them by 5. And you are done. Alright, if we are going to do this, show that it has a length of 1, that just means find the magnitude of u. And so you are going to do negative 3/5 squared plus 4/5 squared and take the square root of that. So this would be 9/25 and 16/25. This would be 25/25. Which would be 1, and the square root of 1 is 1. Alright, so back to this picture to make sure that this makes sense. We're saying that we want these to all be 1 unit long, but we're trying to give their component form. So we want to know how long is this and how long is this for each one of those little pieces. Alright, understanding all of that's not important. You just need to be able to do the math. Alright, so for the next one, we need to find the magnitude of V first. So I'm belaboring the process. I know that some of you can look at that and tell me that the length has to be 4. But if you follow your formula, then you get that this is the square root of 16, which is just 4. Alright, so then to get your unit vector, you're going to do negative 4 over 4 and 0 over 4. These it wouldn't simplify, but these will. So you get negative 1, 0. And then if you want to find the magnitude of that, then you just do the square root of negative 1 squared plus 0 squared, which is the square root of 1, which is 1. Alright, so for C, the magnitude of V is the square root of 1 squared plus negative 1 squared. So that would be 1 plus 1, so this would be root 2. So then we're going to say that U is 1 over root 2 and negative 1 over root 2. And when we look at his answers for homework, he's not going to have radicals cleaned up. He just leaves them alone. So if you leave it like this, I won't take off, but you know that that should be written like this. But when we decide to find the magnitude, it's easier if you work with the uncleaned up version. Alright, we do, it's just one less step. If we square this, we get 1/2. If we square this, we get 1/2. 1/2 plus 1/2 is 1, and the square root of 1 is 1. You can see half what I just wrote. Alright, so The bottom ones, B is pretty easy. E and F get a little more complicated because they got fractions and radicals, but I would say let's pause and at least try B by yourself and then see how you do. Alright, so the magnitude on those three, we're not finding the, we're not going to verify that they get a 1. Okay, so to find the magnitude of B, we want the square root of 2 squared plus negative 4 squared. So that's going to be the square root of 16 plus 4, the square root of 20, which is 2 root 5. And then to get vector u, you're going to do 2 over 2 root 5 and negative 4 over 2 root 5. So you get 1 over root 5 and negative 2 over root 5. And again, I think that's how the guy that wrote this manual leaves his answers. But we know that we should rationalize, and it looks like this. Alright, so for E, if we find the magnitude of V, we're going to have the square root of negative root 2 squared plus negative root 7 squared. And at first you think that's kind of scary, but remember that the square root and the square undo each other, and the negative becomes a positive because it times itself. So this is just 2 plus 7. So this is the square root of 9. So we really just have a 3. So to get vector u, our unit vector, we're going to do negative root 2 divided by 3 and negative root 7 divided by 3, and we're done. Alright, on F, the magnitude, we're going to do 1/2 squared plus root 6 squared, take the square root of that. So 1/2 squared is 1/4. Square root of 6 squared is 6. And this actually works out easier if you think about this as 6.25, because there's a square root of 625. The square root of that is 25. So the square root of 6.25 is 2.5. Or if you left it in fraction form, you would get 5/2. Alright, so if I try to find u, I'm going to do 1/2 over 2.5, which is close, we'll clean it up in a minute, and then root 6 over 2.5. And then if we do 1/2 over 2.5, it's actually easier if you think about the fact that 2.5 is 5/2, because then we can handle both of these a lot easier. I know I don't like fractions, but sometimes I really are the better option. Because here we're going to multiply by the reciprocal, so it'd be 1/2 times 2/5, which is just going to give us 1/5. And then for this one, it'd be root 6 over 1 times 2/5, so you get 2 root 6 over 5. And those would be your components. Alright, so next we're just going to be writing our vectors as linear combinations of unit vectors. There it is. I lost my highlighter. Okay, so the unit vector 1, 0, and 0, 1 are the standard unit vectors. And we call the unit vector that's 1 unit to the right I, and the unit vector that's 1 unit up J. Alright, so these vectors can be used to represent any vector, and we call it the linear combination. Alright, so it makes more sense when there's numbers involved. So let's work some examples, and I know we'll pick up on it, it'll be easy. Alright, so first of all, we have an initial point of negative 3, 7 and a terminal point of negative 5, 2 as vector u. So vector u in component form is from negative 3 to negative 5, so back 2, and from 7 to 2, so down 5. And then vector v, they gave it to us as a linear combination. So this is 3 units to the right, and this is negative 2 units up, so 2 units down. So vector v in component form looks like that. Alright, so they're asking you to write the following as a linear combination. Now the reason I did this is because we need to know what they look like in component form because it's easier. So if I write mu as a linear combination of i's and j's as unit vectors, then it's just, we're going to go negative 2 units for I minus 5 j's. Alright, for the next one, if we do 5 times v, then we get 15, negative 10. And writing that as a linear combination of unit vectors, it would just be 5i's minus 10j's. Alright, here we're going to do 4 times u minus 5 times v. So we have negative 8, negative 20, minus 15, negative 10, which would give us, that would be what, negative 23, and then this would be negative 10. Alright, yeah. So as a linear combination of unit vectors, it would be negative 23i minus 10j. Alright, so pause and try D and E, and maybe F, see how you're feeling. Alright, so negative 5 times V plus 2 times U would give me negative 15, 10, and then negative 4, negative 10, so that would be negative 19, 0. So we just have negative 19i, and you could put plus 0j, but you don't need to. Alright, so negative u just means change the signs of u, minus v, so 2 minus 3, and then 5 minus negative 2, so 5 plus 2, so we get negative 1, 7, so we get negative I plus 7j. Alright, so if we do negative u minus v, we just figured it out, that is negative 1 over 7. And we want to do that over the magnitude of that. So we find the magnitude of negative u minus v. It's going to be the square root of negative 1 squared plus 7 squared. So 49, 50, that's root 50, which is 25 times 2, so 5 root 2. So we do this over 5 root 2. So we get negative 1 over 5 root 2 and 7 over 5 root 2. And again, he's probably going to leave it like that. But if we rationalize, the root 2 comes up to the top. And 5 times 2 is 10, and you have that many i's. And then 7 root 2 over 10 j's. Or you could have just written it like this. I just like to rationalize, and that's a skill that a lot of y'all need help with. So I thought we would do it to see if we could solidify it. Okay, so a little bit more for today. Going on to the next page, we are just going to do the top half. And it's going to bring in the trig that we have learned so far this year. So if u is a unit vector such that theta is the angle from the x-axis to the terminal point, then the terminal point of u lies on the unit circle, and cosine theta sine theta is equal to the component form, and then you can get the linear combination. So it's honestly saying that if we don't know component form, and they just give us the magnitude and a direction, we can figure out the component form and get a linear combination. That's really all this is saying. And so if you think about the fact that you're making a right triangle when you're in the unit circle, or even when you're not in the unit circle, because that's what the next thing says. So what it boils down to is to get component form, we are going to do the magnitude, which I'm going to call R, times cosine of theta, and then times sine of theta to get these two lengths. And then to figure out the angle, if you don't know it, we can use inverse tangent, but that's another story. Alright, R is magnitude, theta is the direction or the angle that they give you. Okay, so R is going to be in degrees, so make sure that your calculator is in degrees, but for most of what we're going to do, actually I think for all of what we're going to do, we're not going to need our calculator. We're going to rely on knowing our unit circle and maybe some SOHCAHTOA. Alright, so they want us to write the vector given its magnitude and angle that makes it the positive x-axis. Alright, so using this little formula. So all of his words sometimes confuse me, so I'm assuming that they confuse you. So what we really need to understand is this concept right here. Alright, so to get our component formed, we're going to do the magnitude times cosine of the angle, and then the magnitude times sine of the angle. Alright, so we know cosine of 0 is 1. So 5 times 1 is 5. And we know sine at 0 is 0, so 5 times 0 is 0. So that's our component form. So we wrote it as the linear combination of unit vectors. It would just be 5i. Alright, so for the next one, we're going to do 8 cosine 30, and then 8 sine 30. So cosine at 30 degrees is root 3 over 2. We have 8 times root 3 over 2. So that's going to be 4 root 3. Because 2 goes into 8 4 times. And then we have 8 times 1/2. So that's just 4. So as a linear combination, that would be 4 root 3i plus 4j. Let me write this smaller so it doesn't all run together like that. So 4 root 3, 4. So we could say 4 root 3i plus 4j. Okay, try the next two, and then check, and then you're probably going to want to do E and F with me. Alright, so for cosine 120, for sine 120. So cosine of 120 is negative 1/2. So it's negative 2. And sine at 120 is root 3 over 2. So that'll just be 2 root 3. Okay. So negative 2i plus 2 root 3j is our linear combination of unit vectors. Alright, so here we're going to do 7/4 cosine 315 and 7/4 sine 315. So we know that cosine at 315 is root 2 over 2. So we get 7 root 2 over 8. And then sine is going to be negative root 2 over 2. So we get negative 7 root 2 over 8. So our linear combination is going to be 7 root 2 over 8. That's a 2 over 8i minus 7 root 2 over 8j. Alright, I'm not going to lie, this next one took me a few minutes when I was going over it myself. So it's okay if you get a little confused. I'll try to explain it the best I can. Okay, and actually was I like forgot that we knew things because we do. Alright, so what they're telling me here is that it's in the direction of this particular vector, but it's not necessarily the same vector. So what I need to understand is that I can get the sine and the cosine from this because I'm saying that I have a triangle where I'm going to go right 2 and up 1, and here's my theta. So I know that the sine of that is going to be opposite over hypotenuse, which is root 2. So root 2 over 2. Where did I get root 2? Because I forgot to. I don't even know what I did. It's not root 2, it's root 5. Sorry, 2 squared is 4, plus 9 squared is 1, 4 plus 1 is 5, so that's root 5. Alright, so this is going to be 1 over root 5 or root 5 over 5. And then for cosine, it'll be the adjacent over that, so it'll be 2 over root 5. So 2 root 5 over 5. So using those, we can say 7 cosine theta, 7 sine theta. We don't need to know what theta is because we know what sine and cosine of theta is. So we can say 7 times 2 root 5 over 5, which will give us 13 root 5 over 5. And we can say 7 times root 5 over 5, so 7 root 5 over 5. Right, so it's not so bad, but I was for some reason not wanting to stop and think of it like that, and it took me forever to figure that out. Alright, so F, which they kind of bring together on us, but F is roughly. So we have a magnitude of 2, and we're in the direction of this. So from where I start, I go -3, +4. Let me draw that over here. From my start, I go -3, +4. So this is my vector. So -3, 4, we know this is 5. So we can say that sine is -4/5, and cosine of theta is -3/5. That's not -4, it's going up. I really do need to. I'm going to take a nap. So this is +4/5. So we can say that we're going to do 2 cosine theta, 2 sine theta. So 2 times -3/5, so -6/5. And then 2 times 4/5, so 8/5. So we get -6/5 I plus 8/5 j. Okay, so that's it for day 2. So on your homework pages, you're going to do page 12 and 13, but you're only doing 5, 6, and 7. So numbers 5, 6, and 7, all the parts. If you have questions, please let me know. I will do my best to answer them.